Part 1. Assuming derivatives are cosh and sinh, show the derivatives of cosec x and coth x are those. Right, so let's start with cosec x first. That's equal to 1 over sinh x. So I can do this as a quotient. U over v, so u is equal to 1, v is sinh x, du is 0, dv is cos x. So the derivative then, so dy by dx is v du, so that's 0, minus u dv, which is cos x, all over v squared, which is sinh squared x. So that's minus cos x over sinh squared x. Break the sinh squared x up on the bottom, so that's minus cos x over sinh x, and I can put a 1 there. So minus cos over sinh is minus coth, 1 over sinh is cosec. So there's the first one, and then derivative of coth x. Coth is 1 over tanh, which is cos x over sinh x. So that's u over v. So u is cos x, v is sinh x, du is sinh x, dv is cos x. So dy by dx is v du, so that's sinh squared x minus u dv, which is cos squared x, all over v squared, which is sinh squared x. Right, the top line is sinh squared minus cos squared. Well, I know that cos squared x minus sinh squared x is 1, so that top line is minus cos squared minus sinh squared, which is going to give me minus 1 over sinh squared x, which is minus 1 over sinh squared x, which is minus cosec squared x. Second part, hence show that the differential, so I want to differentiate that expression, so dy by dx will be, right, differentiate log is 1 over, so it's 1 over cosec x plus coth x times the differential of the bracket. So the differential of cosec x is minus coth x cosec x plus the differential of coth x is minus cosec squared x. So that's minus, right, common factor is cosec x, minus cosec x bracket coth x plus cosec x over cosec x plus coth x. So that will cancel that, give me minus cosec x. Right, part B. So the length of the arc joining the points 1, 0 and E1 on the graph of y equals log x is given by that. So the length of the arc from the formula booklet, the length of the arc in Cartesian form is the integral of the square root of 1 plus dy by dx all squared dx, and the limits here, the x values are going from 1 to e. So y equals log x, so dy by dx is 1 over x, so 1 plus dy by dx all squared is 1 plus 1 over x squared, is 1 plus 1 over x squared. So sort the fraction out from both over x squared. So the first one is x squared over x squared plus 1 over x squared plus x squared plus 1 over x squared. So the length of the arc then is going to be the integral from 1 to e of the square root. So it's the square root of x squared plus 1 over x squared dx. Right, the square root division, so square root them separately. That's the integral from 1 to e of the root of x squared plus 1 over square root of x squared is x dx, which is what they've got in part 1. Okay, in part 2, tell me to use the substitution x equals sin u. Okay, so x equals sin of u. So I need to change everything to u values. So if x is 1, then 1 is sin of u. Gives me u is sin to the minus 1 of 1. If x is e is sin u, which gives me u is sin to the minus 1 of e. So that's the limits. So together dx, x is sin u, so dx by du is cos of u, so dx is cos u du, and I'm ready to substitute into this integral. So 1 to e, 1 is mapped to sin to the minus 1 of 1, e is mapped to sin to the minus 1 of e. Right, the top line is the square root of 1 plus sin squared u over x, which is sin u, and dx is cos u du. And then cos squared u minus sin squared u is 1. So cos squared u is 1 plus sin squared u. So to get a square root, I can't square root a sum or a difference. So the fact I can rewrite that as cos squared u will allow me to carry out the square root. So it's the integral from sin to the minus 1 of 1 to sin to the minus 1 of e. Okay, so that's the square root of cos squared u, cos u du over sin u, which is integral from sin to the minus 1 of 1 to sin to the minus 1 of e. Right, square root of cos squared is cos, that'll be cos squared u on top, sin u on the bottom, du. Right, I want to show that that's equal to cosec plus sin. Okay, so the top line isn't, that's not going to give that to me if I do cos. If I can't split up the fraction because the product term's on top. So cos squared u is 1 plus sin squared u, so I'll go back to writing it like that. Cos squared u is 1 plus sin squared u over sin u. Now I've got two separate fractions, so I'll have two terms. Sin e on top. So it's 1 over sin u plus sin squared u over sin u, which is, I think I'm there now. 1 over sin u is cosec u, and sin squared over sin is sin. And that's what they asked me to do. And then the last part is telling me to use the result in A part 2 to determine the value of L. Okay, now to use the result of A part 2, which is here, then from A part 2, if I differentiate this side to get this side, then if I integrate this side I get that side. So A part 2 is telling me that the integral of cosec u du is minus ln of cosec u plus cos u. So integrating what I've got then, so integral of cosec u is this, minus the log of cosec u plus cos u, and the integral of sinh u is cos u. I put the limits in from sinh to minus 1 of 1 to sinh to minus 1 of e. And then it's just a matter of number crunching this. So that's just on the calculator, we put in the height. Right, I don't have a cosec u, so this is going to be minus ln, right, to get cosec of u, so that's 1 over sinh u, so that's 1 over sinh, and that's going to be sinh to minus 1 of e, plus cos u, so I have to rewrite that as cos, that's cos of sinh to minus 1 of e, over sinh of sinh to minus 1 of e, plus cos of sinh to minus 1 of e, that's the first bracket, minus ln of 1 over sinh of sinh to minus 1 of 1, where's the log, sorry, black stuff there, plus cos of sinh to minus 1 of 1 over sinh to minus 1 of 1, plus cos of sinh to minus 1 of 1. Okay, looks absolute mess. Okay, so let's see if I can get all this on. Well, hopefully I can get it to be there. So it's minus ln 1 over that sinh of height sinh to minus 1 of e close bracket, oops, plus bracket cos is 2 4 into 1 close bracket over height percent of 1 4 into 1 close bracket plus cos 1 into 1 close bracket. Right. We haven't put a bracket in there somewhere. Let's go back. Squash close the bracket there, close the bracket there. Plus cos since the minus 1 v to 1, close bracket, close bracket. Ah, there it is, with a bracket there. So that first bracket is going to be minus 1.46551842, and then I have to substitute. So then I could change all my e's into ones. So let's go back to the start. The first one. Right. So e is to ones. That's minus 1.42. Minus that versus minus there. Okay, I'm an error on the calculator here. Okay, that's not going to come out, so I made a calculator error. The answer should be okay, 2.00.